Okay, welcome. Today's lesson is 97. It's recursive rules for sequences. What's our objective, class? Get ready?
Recursive rules for sequences.
Very good. I like Layla's eyes are up front. Jasmine, thank you for having your eyes up front. Today we're going to learn how to find missing terms in a sequence. We're going to write a rule for a sequence. What's different about today is we're going to be, instead of using an explicit formula like it's the nth term times 3, instead we're going to say it's the previous value plus something, or the previous value times something. And when we use the previous term, that makes it a recursive formula. What kind of formula? Get ready?
Recursive formula.
Recursive. I like to think of the word recursive as like I'm rewinding or reviewing. I'm looking at something that happened previously. Okay, so review or reverse. All right, so take this sequence. If we had this before, 3, 6, 9, 12, the first term is 3, second term is 6, third term is 9. And we used to say, oh, it's the term number times 3. Term number times 3. That's called an explicit formula. If you use the term number to find out your formula, it's an explicit formula. What?
Explicit formula.
An explicit formula. If we don't use the previous term, but rather, if we don't use the term number, but instead use the preceding or previous term, then it's a recursive. Hold that thought for just a second. So here we have first term is 3, second term is 6. So instead of looking at term number, I want you to look just at the value. How would I find the 6? What did I do to the 3 to get a 6? What do I do to the 6 to get a 9? What do I do to the 9 to get a 12? So when we look at it in that sense, that helps us find the recursive formula. Jasmine?
It's 6 plus 3.
It's plus 3. So to find this term, I would take the previous term and add 3. So how do I say that mathematically? Whenever we write a recursive formula, we have 2 parts. How many parts? Get ready?
2.
2 parts. The first part, we have to tell it the first term. What do we tell it first? Get ready?
First term.
The first term, because we want to say, where do we start our pattern at? We start our pattern at 3. So the value of our first term is 3. That's important. Like if I had a population and it was growing by 3 people every hour, or 3 people every day, or 3 people every year, then I would say, well, my population started at 3. That's important, right? If my population started at 200, it'd be a completely different sequence. So my population starts at 3. And then from there, I take the previous term, or that starting term, I add 3. And I take that term and I add 3. So in math, what we say is to find the value of any term, I find the previous term. What do I find? Get ready?
The previous term.
Previous term, but we don't want to write out the word previous term, so instead we have a cool way to write that. We write a sub n minus 1. So this says back up 1. A sub n minus 1. What?
A sub n minus 1.
Good. And then we're going to add 3 to that. Let's just check to make sure it makes sense. If I wanted to find the 6th term, I would back up and look at the 5th term and add 3 to that. Okay, that's making sense. If I wanted to find the 7th term, I would back up to the 6th term and add 3 to that. And that's why we use a recursive way of writing it. We're saying the previous term. What does a sub n minus 1 mean? Get ready?
Previous term.
The previous term. That's super important. All right, so I put that in bolded there. Use a sub n minus 1 for the previous term. I'm going to show you an incorrect way to write it that a lot of students do. I want you to see if you can catch the mistake. Okay, Spencer?
Instead of it being n minus 1, it's an minus 1.
Mm-hmm. You almost say it the same, but it's too big. I wrote it too big. You have to write it, make it obviously small down there. And then whatever you're doing, if you're timesing by 4, write it big, the same size as the a. So you know this is previous term. Whatever that value is, times that whole thing by 4. You're not timesing the 1 by 4. You're timesing the whole thing by 4. All right, let's try one. This one's a cool one. This formula is doing something where it's getting big. Maybe this is bacteria. You're starting your colony with 2 bacteria. And you get 4. And you get 8. Suddenly it's getting really big. What is the rule happening to this term to get the next term? Okay, what do you see, Addison? Times it by 2. Does it work every time? Yes, it does. So, if I said my rule is times by 2, oh, we forgot to do this. First term, second term, third term, fourth term, fifth term. Value is 2, the value is 4, the value is 8, 16, 32, so forth, so on. So I write my rule. I say the value of the first term is what? What is my first term? Think. Okay, ready?
2.
So good. That's like my starting bacteria number. Then to find the value of any term, Addison said you times it by 2. How do I say, what am I timesing by 2? What am I timesing by 2? What do I write here to say that? Jasmine?
A and then like a small n minus 1.
Very good. A small n minus 1. And then my times 2, I can do a x. You know what's even better is if I write the coefficient in front, like that. This is even better. In fact, my answer book mostly has this, but I'll take this because I know it is commutative, so it doesn't matter where the 2 is. All right, any questions? Okay, so the recursive formula has 2 parts. How many parts? Get ready?
2.
2 parts, the first term and then the nth term. Make sure you put both. Make sure they have equal signs. Okay, well, what if they don't give you any numbers? They only give you an explicit formula, and they said you got to figure out the numbers. So let's figure out the numbers. 1, 2, first term, second term, third term, fourth term, fifth term. The value of the first term would be 2 times 1 plus 1. Think. Get ready?
3.
3. The value of the second term is 2 times 2 plus 1. Think. Get ready?
5.
5. Value of the third term, 2 times 3 plus 1. Get ready?
7.
Excellent. Do you have enough to see the pattern? And usually you can find it in 3 numbers. The next one is, get ready?
9.
The next one, you ready?
11.
Very good. Okay, so now we've got our table. Let's start our pattern. First term, what's the value of my first term? Lexi? 3, excellent. The value of my nth term. How do I write previous term? Oh, well, what is the rule? What is the rule? What am I doing? Annika? Adding 2. You got it. Every time it adds 2. So I got my pattern. It works every time. How do I say previous terms? Sophie? A sub n minus 1. And then add 2, right? Done. Give me a thumbs up if it mostly makes sense. Okay, any thumbs down? A little confused. All right, we have a couple medium thumbs. Let's do one more. All right, suppose they give you the recursive formula and they want you to find out what the values are. So let's make a table. And I hurt my shoulder over the weekend and my knee. It's playing steal the cup. And I'm like sort of like I gotta write everything really low. First term, second term, third term, fourth term. The value of my first term they tell you. Colin? 5. All right, they tell you the value. So now I know I'm starting at 5 bacteria. Let's find out what's the bacteria doing. Oh, it says it takes the previous term, which this is my previous term. To find the next term, I will times it by 3. So I'm going to do a times 3. 5 times 3 is 15. To find the next term, I times by 3. So what's my next bacteria colony? Lauren, can you do mental arithmetic on that?
45.
Very good, 45. Let's say down here somewhere they said that population of the bacteria is 405. We don't know what term number it is, but they want to know what would it be 1 hour later. What would be the population? I don't know what hours it is, but I do know it's tripling. So the very next hour it should triple. Ethan? 1,215. Ever see what he did? He just times by 3. Okay? So they'll call this the following term. This is the previous term. This is the following term. Any questions? Alrighty, we made it. We're on page 648. Take a stand-up break for 20 seconds.